the YouTube and let students see here.
Already broadcasting.
Bom dia a todo mundo, bem-vindos ao nosso segundo episódio da série de palestras de introdução à engenharia de som. E hoje a gente vai ter a palestra da doutora Elżbieta Nowicka. Ela se formou em fonoaudiologia e arquitetura e atua já há bastante tempo na área de acústica, né, com toda essa experiência, especificamente no Institute for Building Research, na Polônia. Mas, além de uma pesquisadora de longa data em acústica, ela também adora tirar fotos e ela gosta de correr atrás de balões de ar. Então, ela participa de diversas competições de balonismo como fotógrafa oficial. Então, é uma pessoa aí com um amplo espectro de habilidades. Mas hoje ela vai contar para a gente um pouco do que ela tem feito na área de pesquisa em acústica dentro do trabalho dela. So, Ella, first of all, thank you for accepting this invitation. And we are all very curious to hear about what you have to tell us. So please, the floor is yours.
Hello, everyone. First of all, I welcome you here in my home. Of course, it's connected with lockdown in Poland. Right now, we have to we shall work from not from our office but from our home. So, welcome. And I would like to say something about my research. My research is mainly focused on acoustical assessment of enclosures at the early design stage. So my scientific work is focused on is mainly for architects and for designers. This is not for acousticians. This is for designers. But maybe first I will describe my way to architecture. I'm sorry. So my way to architectural acoustics is, of course, connected with my education. So it began with primary and high school. It's a normal educational way in Poland. And then I decided first to go to university and to start study hearing prosthetics. So it was about hearing aids, but it allowed me to have knowledge about how people hear sounds and how they react to sounds. But it was only to bachelor. Then after bachelor, I decided to do a Master of Science degree, and it was in physics with specialization acoustics. Actually, it was architectural acoustics. So it was my first connection with architecture, with acoustics. But in the same time, when I was studying hearing prosthetics, I decided also to go to technical university. So it was the second university. And I decided to study architecture. And in this case, I was able to connect acoustics and architecture together. And in the end, I realized that there is, of course, we know as acousticians that there is a big connection between acoustics and architecture, but I saw that architects don't have knowledge about acoustics. Actually, it is the big problem in Poland many times that architects they are designing the buildings.
It's not exclusively with Poland.
Okay. I didn't want to say about any other countries, but I know it is not only Polish problems. So actually, this connection, this educational process, architecture and acoustics, allowed me to connect it in my scientific work. So in my scientific work, I'm trying to make a connection, a bridge between acoustics and architecture, but I am mainly focused on the how to translate acoustical language into architectural one. So how to do this, that acoustics may be more easy for architects. And after all my university story, I went to Building Research Institute and I did my PhD in construction science, but my PhD was my first scientific research in assessment of enclosures. Maybe I will try to say something about Building Research Institute. I work in the acoustical laboratory. So I would like to introduce my laboratory. We are accredited laboratory and notified body. Notified body is a European CE marking procedure, but also we are accredited. So our testing reports may be influenced or implemented in many countries, not only in Poland. We are accredited in many methods. Mainly, we are doing sound insulation and sound absorption tests. Also for airborne and impact sound insulation. It is in laboratory and in situ as well. Also some testing of materials like dynamic stiffness or airflow resistance. Some room acoustics testing also, and fire alarm systems. Actually, right now in our accredited list, we have 32 test methods, both for laboratory, including laboratory and in situ. Our laboratory was started in 1959, so it's quite old one. You can see some old pictures, including old anechoic chamber, or as you can see, this is one of the first tapping machine. So as you can see, this laboratory is quite old. Right now, we have 11 test chambers for sound insulation, 9 for sound insulation, 1 is reverberation chamber, and 1 is anechoic chamber. We have 2 sets for airborne and impact sound insulation chambers. One set is big ones for walls, for big samples, around 10 square meters, as you can see. So one volume is 100 cubic meters, and receiving volumes are 93 and 90. Depends if we are talking about sound insulation or impact sound insulation. Another set is smaller. This is mainly for windows and doors and inlets. So as you can see, the volumes are also a little bit smaller. And this set of chambers is a newer one. The previous one was the oldest from 1960s, and this one is from 2000. Sorry, it's from 2000 year, so it's much younger. We have also the measurement test chambers for longitudinal airborne sound insulation. So this wall, so you can see this wall is elevated. It might be elevated to up or lowered down. Depends if we are measuring suspended ceilings or elevated floors. This is only one test chamber, this kind of test chamber in Poland. And only few of this is in Europe. And some measurement equipment for material testing, dynamic stiffness, airflow resistance also. Here we have another test rooms for impact sound insulation. This is a special room with a floor structure. So this floor structure here is permanent. So we are using this if we want to measure floor coverings. So we are doing in this test chambers. And of course, chamber reverberation room for sound absorption coefficient, and anechoic chamber. This room is for measuring sound alarm systems, for loudspeakers for sound alarm systems. We are doing, of course, many typical measurements, but I would like to show you some extra special cases. So, for example, here we were doing impact sound for flights of stairs, for staircase landing. So here the sound insulation of the insulation of this staircase landings, and for example, also vibration propagations along the curtain walls mullions. And it was also very nice and tricky for us, facade insulation on the 29th floor. So it was one of the highest buildings in Poland, and we were measuring in this building sound insulation. So as you can see, we are doing many measurements. But everything is connected mainly with building acoustics and architectural acoustics. So this is our goal of this is the main goal of our laboratory. If you are interested more about this laboratory, there is a short movie, 7 minutes, about our laboratory. Unfortunately, I'm really sorry, it's only in Polish. But you can see at least how it looks on the movie, not on the pictures.
I think Google can translate it for us, doesn't
I hope so. Maybe we will make subtitles one day for this movie. So you can find it on the website of Proper Sound. It was a guy who was doing this movie. He had a special project for this. He made movies about different laboratories in Poland, acoustical laboratories in Poland. So one of us, our is also was included. So if you are more interested about the laboratory, you are welcome to see this movie. Okay, so right now I would like to say something about my scientific work. It's about acoustical assessment of enclosures at the early design stage. Why I decided to do this work is actually the main problem in my real work was that many times architects were coming to me asking for to help them because they have a big problem mainly with sound alarm systems, and sound alarm systems were many times were correct, but the acoustical properties of the room were not very good for speech intelligibility from the sound alarm systems. And but the problem was that these architects were coming only when the building was built or under construction. So everything was designed, everything was the materials were chosen, so everything was done, and suddenly they came to me and said, please help us because it's not working. And many times I saw that architects didn't have any knowledge about acoustical, about room acoustics, about architectural acoustics. I know that because I was studying architecture. So during my studies, we had only 3 lectures during 4 years of studies. So it was not enough to have any knowledge about this. So I decided that architects need some very simple methods, very simple and very easy methods to help them and make just first simple question: how can I properly design my building, my room, to make it good from acoustical point of view. I know that what I'm doing is very easy for acousticians. For us, it is like ABC. We know this, it's so obvious, but it is not obvious for architects. So that's why I'm trying to translate this acoustical knowledge, this acoustical language into architectural one. And of course, I decided to focus mainly on the public buildings, like everyday life buildings, such like swimming pools, train stations, this kind of buildings, because it's in this kind of buildings, in Poland at least, we have many requirements concerning sound alarm systems. Sound alarm system has to, they have requirements about speech intelligibility. So right now in many buildings, sound alarm systems is mounted, but the speech intelligibility is horrible, and many times the building cannot be open because of this problem. What is also another problem, we know as acousticians that there are a lot of calculation methods using softwares like Audion or EASE or different one. So many softwares which may be used during designing process, but I know also from my work that not every architect is interested in cooperation with acousticians during this early design stage. Many times they are asking for help in the normal buildings, like the public buildings. They are asking for help when the building is under construction, for example. Yeah, they are asking for help if they are talking about cinemas, if they are talking about operas, theaters. This is so obvious for them that operas, theaters, this is acoustics. But they are not aware that swimming pool, underground station, open plan office, different kinds of typical buildings, they also need some acoustical advisor. So that's why, again, I decided to develop very simple evaluation procedure for architects to help them to design build this kind of rooms easier. This method shall ensure the proper speech intelligibility, and it also shall reduce indoor noise, for example, by reducing the reverberation noise in this room. And of course, it's mainly focused on the using of voice alarm systems, because in Poland actually, but I think it's not only in Poland, it is very important. Many buildings cannot be open because voice alarm system is not working properly. So these results shall clarify for architects the criteria for assessing the acoustical climate for different kinds of public spaces. I will tell you which kind of spaces I developed till today. And it also shows familiars to designers knowledge of the area of acoustics. And what is important for me, it must be easy as much as possible. it cannot be difficult, because if it will be difficult, the architects will not using this. So what was my also main goal? To do this as easy as possible, to make this procedure very easy for architects to use during early design stage. So this method might be used even when the architects are doing first sketches, first ideas of the room, first ideas of this enclosure. They are able to use this this method. Till today, I developed this method for 4 types of public spaces. First one, it was for long enclosures, mainly like underground stations. It was caused because in Poland, in Warsaw, right now there's a huge construction of the underground stations, and actually they are not very properly designed for voice alarm systems, and of course there are some problems. Next one was sports spaces, including gyms or swimming pools, then open office and shopping spaces in the end. Right now I'm working on the eating places like restaurants or cafeterias in schools and so on. So I will try to present you some of my procedures. First, it's long enclosures. It's mainly focused on the underground stations. You can see 2 underground stations from Warsaw. What is a problem, as you can see from these pictures, is there are no absorption elements actually in this room, and nobody was thinking about any absorption during designing stage. So when I was working on this method, on this assessment procedure, I figure out that there are some parameters describing long enclosures, and these parameters influence the acoustical parameters of these rooms. So I divided them into 2 groups, architectural one and acoustical. Architectural one is the first cross-sectional shape of the space. It influences the reverberation time in the long rooms. Then is the volume, and of course architectural elements absorbing and scattering sound. The second group is acoustical one, so it's mainly the reverberation time and presence of the sources of constant sound. So the procedure is like a sum of sub-indexes. Every index is for different parameters, which I showed you on the previous slide. So the cross-sectional shape index, space dimension index, index relating to sound absorbing objects, sound scattering elements, reverberation index, and acoustic background index. And I prepared special table for architects. And this is in this procedure, we are doing a sum of these indexes, and every index has its own number value from 0, from the worst case, till maximum 2 or 5 or 4 for the best case. Of course, it depends when it's 5, 4 or 2, it depends how big influence is of this index is on the overall acoustical situation in the room. So of course the reverberation index or volume is those indexes have bigger influence on the acoustical situation than, for example, shape of the cross section or acoustical background. So we can see that from, of course, from the worst situation, for example, cross-sectional shape like the round one is the worst one. And rectangular one is the best one. There's also index relating to sound absorbing objects based on ceiling surface area. So if we have 100% of absorbing ceiling, then we are giving 4. If there are no absorbing, of course, we are giving 0. And we are doing a sum of this all indexes. What I'm doing with this sum, I will tell you in the end of this presentation. But I would like to show you that this method is easy for us, for acousticians. It's like ABC. Everything is very obvious, but it is not obvious for architects. What is also easy for architects is that if the sum will be too low, if the number, the whole index, it will be too low, then architects may see what to do to make it better. So from this table, he is able to see what to do to make this room much better. For example, he may make the volume smaller, or he can change the shape of the cross section, and so on and so on. Okay, the second one was sport spaces. So it was the same procedure. Like again, I divided parameters to architectural and acoustical one. For each parameter, I prepared the special index, and again, I prepared a table with the values for each index. And again, you can see that some of them, like sound absorbing materials, this is the big one, the bigger one, but shape of the ceiling or sectional shape of the room is also the smaller one. So this is for indexes which has smaller influence on the acoustical climate in the room. Then the index has a smaller values. Next one was open office. In open office, maybe not in this case, the sound alarm system is not so important. More important is acoustical conditions to receive the spoken text and to ensure the privacy of conversation. So in this case, it was different problems. Of course, every open space enclosures has their own problems and factors influencing the acoustical parameters, like again, like room dimensions, the furnishing in the room. So again, I developed parameters, architectural and acoustical one, which influence the acoustical climate in this room. And again, I prepared indexes and special table with the numbers. Here there are some special indexes connected with workplaces, like distribution index and enclosure index. If the workplace is concentrated or distanced, about the enclosure is open or enclosed. What does it mean? Here we have some in green there is a dispersed workplace, and in red there are concentrated workplace. So this kind of workplaces also influence the acoustical climate in this kind of rooms. About open or enclosed, also there are different kinds of workplaces in open office, so it also may influence the acoustical climate. And the last one, shopping spaces. The last one I want to show you, this is shopping spaces. Shopping spaces, again, it's the problem is about voice alarm systems. sound alarm systems. If I am talking about commercial buildings, it includes the big ones: supermarkets, hypermarkets, shopping centers. I decided after the data from literature or real shopping buildings, I realized that some properties special for shopping influence the acoustical climate. So, for example, the equipment or types of products. For sure, it's different if the shop is with clothes, and there are different situations if the shop is with glasses, for example. Different density of shelving. Again, we have shops that are only few shelves and nothing more, and there are shops with with a lot of numbers of shelves. And shelving arrangement also may have influence on the acoustical climate. Again, few parameters which are influence the acoustical properties of the commercial spaces, and indexes with numbers. As you can see, the volume and reverberation time it has the highest numbers. Shelf companion or shelf shape of space also it has not so big problem. Okay, what to do with the sums, with the sum of these indexes?
That was my question. I was really curious to know about that.
So there are 3 classes. From 0 to 8, it's bad acoustic quality. So for sure, the acoustical climate will be horrible. There will be a problem with voice alarm systems, with speech intelligibility, and it should be noted, if you have from 0 to 8, please call Elżbieta Nowicka. From 9 to 50, it depends. It might be okay, but not sure. Maybe it's good if you are ask some acousticians to be sure that acoustic quality will be okay. From 16 to 20, the acoustical quality should be good. There shall not be problems with speech intelligibility, and all parameters probably were selected properly. So, as you can see, I hope that this method is really like a bridge between acousticians and architects. So it is like translation, the acoustical knowledge, the acoustical language into architectural one. The method described to architects how these parameters shall be chosen properly, and what to do to make the room, the enclosure better, and how to do this during this early design stage. So during these first sketches, during for example, when they are choosing the materials for design, and so on and so on. Of course, this is preliminary analysis, so it should help, but it's not solving all the problems. Of course, the Audion, EASE, and other methods are much better and much more. Sorry, so maybe this method is my method is very overall. So this is preliminary overall, just the information where we are with this room. Is it good or is it bad? If it's bad, then call to acousticians, because you might have some problems. About publications, if you are more interested in this method, there are two publications about commercial spaces and buildings in applied acoustics, and about long enclosures in the tunneling and underground space technology. Another one will be, I hope, will be published soon. Thank you for your attention.
Thank you very much, Ella. For clapping already.
Clapping.
But, really interesting. I already have some questions that I would like to start throwing at you.
Okay.
And what has this method been used in practice? Have you used it with architects on their
This
daily
method
basis,
was
or with students?
This method was used by Polish designers, and sometimes it was used also by Polish acousticians, because they realized that this method helped them to talk about acoustics. So when the architects and designers, they show this method, so they realized what is the problem. So they used this method to during discussions with architects, because it was like a help for them.
Mm-hmm, perfect. And what was the response you gathered so far?
So far, it's very good response. Yes, I have a good response, and a lot of acousticians and architects are interested in this method. Yeah.
Cool. One curiosity from my side: how did you get to the numbers? What was the methodology behind? You don't have to go into details, but how did you get to the why some go to 5 and some go to 2? How was this?
I think it's just a overall acoustical knowledge. We know as acousticians that which parameters have a big influence on the acoustical climate, and which one they have smaller influence. So volume is obvious. Yeah, this is volume is influencing the reverberation time. Reverberation time is influencing the speech intelligibility. Is obvious. Yeah. Absorption, the same. Absorption is influencing reverberation time, and so on and so on. But of course, we know also that the shape of the room, or the shape of the walls, like in the sports enclosures, it's also influenced, but not so much. So in these cases, we know that it may help to improve the acoustical climate, but it is not solving the problems. Solving problems is by volume, by absorption. By shape is improving.
Mm-hmm. Yeah, really related to that, Guilherme is asking which are the most relevant parameters. So you already talked volume, absorption, anything else? I think.
May I ask something, Bruno?
Yes, if you want to include.
Yeah, are your models related to the type of the construction? Because I was thinking about if we try to translate for Brazilian, let's say, do you think it may work? Because I see that the construction structures from Europe and Brazil, they are pretty much different.
I don't have knowledge about Brazilian constructions, so
yes.
I don't know the differences between Brazilian and European buildings. But I suppose that it shall work in Brazil also, because the acoustical knowledge is the same. In every building, there's a volume, there's absorption, and there is a shape, and there is furnitures, and so on and so on. So I hope it shall work also in Brazil.
Yeah, no, I was just wondering, because our insulation is usually very bad, and so in this case, we would find a different coefficient, for example.
Maybe, but this method is not about acoustical parameters. This method is not about acoustical requirements. This method is how to design buildings better. So I'm not talking about requirements, especially because requirements are different in different countries.
Yeah.
I am more focused on trying to translate to architects how to do this, how to create buildings and enclosures better from acoustical point of view.
I see. Thank you.
Yeah, and then in the end, if you have this framework, as Ella is showing us, it will make clear that you want to make, if you want to have good intelligibility, you want to have your space small or have more absorption, and this trade-offs, that I think that's why you're saying that the acousticians enjoy that, to talk, make it easy to talk with architects.
Yeah,
right?
exactly, because when the architects are doing this method and they have a sum of points, yes, for indexes, and the number is too small, so they can see from the table what to do to make it better. So you don't have to translate then, you know, if you make the volume smaller or put more absorption, he can see, yeah, if you make it smaller, okay, then you have bigger number, and then it shall be better, yeah, and so on, so and so on. So architect may use it during first sketches, and then he is able to assess his enclosure very fast, and then he's able to make the decisions faster, yeah, and better.
Right. Can I ask a question, Bruno?
Go. Yes, of course. Go for it.
All right. So thank you very much for this lecture. We had, just as a side note, we had about 130 people coming, about 90 on Zoom and 46 on YouTube live stream. So I think it's, we are not keeping a ranking, right, Bruno, about, all right, so, okay, not a competition. So, but it's a lot of people, so thank also everyone for joining. And so my question is, we see here in Brazil a lot of talk in the engineering sector and in the architecture sector as well, about to use building integrated management. So I was wondering if that's the case in Poland as well, and how you see if this can actually add to the conversation between architects and engineering and the difficulties of using this kind of technology in acoustics.
Right now in Poland, acoustics is not so important, but hope it is more and more important. So I can see from my work that many years ago we had just few questions about to help to architects. Right now it's more and more, so they are more aware, but still it is not in the process of the assessment of the building. Only the assessment method for open office buildings. Then there is a method. I think you shall know it, because it's quite worldwide, as I know, BRI method or something like this. Yeah. So over there is some acoustics parameters, but as I remember, it's only connected with noise. So still the speech intelligibility is not very famous, but in Poland we had a few very famous cases, like in Warsaw, the airport, the main airport, at the big building, it was not open because of the problem with speech intelligibility. And so this problem is the architects and engineers and controllers that are more and more aware about this, but I hope it will be more and more better. Still not enough.
Going back to the method you presented, is it finished, or is it a still a work in progress? With the method, with the numbers, and getting the
it's in process, but maybe not about numbers, but about other types of buildings. So right now I am working on eating places, like restaurants, cafeterias, but like cafeterias in schools or universities, the big one, cafeterias and so on. So I'm working on different types of buildings.
Okay, so you're expanding the mod. The framework is done, but you're expanding into different types of constructions.
Exactly.
Okay, that in that regard, there's a good question here. I don't know if Victor, do you want to open the mic and ask, or should I?
Okay, thanks, Bruno.
Sure.
I think my
We're hearing you well.
My speech in English is not very good, but I'll try.
It's really
like mine.
My question is, how can I apply the models in, for example, building a room in my house for recordings? Because I wanna have some recordings in my house, and how would, for example, an interesting design of the walls and the ceiling for a room less than 200 meters. I don't know how to say.
Okay, I wrote this. I wrote this question. So my method is right now is not for recording studios at home. I'm focused on the public spaces. Public spaces and the problem of speech intelligibility in the voice from the voice alarm system, from the sound alarm system. So your case is totally different one, and I'm not sure if I am able to explain what to do to make a recording studio at your home properly. This is a long story about designing this kind of studios, because you need very short, first you need very short reverberation time, and then you have to also be focused on the low frequencies, because this might be a big problem. And you have to also assure a good scattering from your walls. So it's totally different problem. So this method is not for recording studios at home. I'm really sorry.
No, thanks very much.
But it's good to know that there are things that work for certain situations and they don't work for others. And yes, designing a studio, even a home studio, it's a completely different framework. It's a completely different thing. Now I was thinking if we will have someone on these talks about that, but I don't think so. But we can include that on a new talk in the future.
Yeah, of course.
Luis Miguel, do you want to go ahead and ask?
Hi, good morning. I'd like to ask you if you had some examples of the methods in action, and maybe some comparisons between your method and some traditional acoustic parameters like intelligibility and so much.
The method was used in action mainly with the long enclosures. It was used for sure. It was used in the tunnels in Poland, but tunnels for cars. And in Poland, in this kind of tunnels, there have to be also sound alarm system, and there was a problem, of course, with speech intelligibility, because the typical car tunnel is the volume is big, no absorption, a lot of noise from ventilators, and of course the speech intelligibility was almost zero. And my acoustical friends told me that they used my method to show to architects what they did wrong, and why it's not it's impossible to assure the speech intelligibility. So I know this it was used in this action for sure, as I know, but and also another friend also told me that he was using this acoustician was using this also in a sport enclosure, and also during discussion with architects. So this is what I know.
Yes, one question related to what you're saying is Marcel is asking if you use other parameters beside the speech transmission, speech at the STI, the speech intelligibility. Are you looking at any other parameters for speech intelligibility?
In the public places, no. This is the main problem, because this is the requirement, and in this kind of rooms, it is a very big problem to assure this parameter, because mainly I think it's the same in Brazil. When we are talking about public places like shopping centers or like airports, this is a big volume, no absorption, noise from the ventilation
different
system,
sources.
or different sources, and then the building is constructed, everything is mounted, and suddenly no sound, no speech intelligibility, and there's why. Do something. And so many times it's like we are not able to do anything, yeah, or
No,
if you want to do something,
late.
it will be very very
expensive.
exactly. So
yeah,
I am focused only on the speech intelligibility. Yeah.
That's why we are telling everybody, thinking acoustics at the right time. Then that's in the beginning of the project. Lucas wants to ask you something as well. So please, Lucas.
Hey, Professor. Thank you for your lecture in the first place.
Hello.
Can you apply your method to a classroom? Is it considered a public space?
I was not developing my method for classrooms yet. I'm not sure if I will be working on this on the classrooms because actually I don't know. I haven't decided yet.
I think I caught you a little off guard here.
You know, Lucas is Lucas has he's finishing his degree in civil engineering, and he will work with acoustics of classrooms, and I guess that's why he's asking this. maybe he can apply your method to a classroom and see if that works.
I could do that.
Or maybe you can help me to develop the new one for classrooms.
Sure, you can work together.
Yes.
Yeah.
See, Lucas, you have another co-advisor.
Yeah, I'm getting like a list.
Okay.
Cool.
Thank you, Professor.
Thank you.
Luis also has a question. Please, Luis, if you want to go ahead.
Hello, good afternoon. Thanks for your lecture. Dr. Elżbieta, is that pronunciation correct? How should I pronounce your name correctly?
The full name in Polish is Elżbieta, but Ella is also okay.
Ella, oh, okay then. I would like to ask you if you think it will be worth the effort to apply some machine learning models, maybe to finesse this model, the use of these coefficients of these parameters to have maybe a more precise indicator. If we had a large number of measurements, maybe for different spaces, because I imagine that for applying a machine learning model, we would need a lot of measurements, and that would be very time consuming. But if we had this data, do you think it would be worth the effort?
but you have to remember about one thing. The main goal of this method is to do as easy as possible. If it will be more complex, then the architects will not using this. And this is for architects. This is not for acousticians. For acousticians, we have Odeons, ease, and all other methods, better or worse, but we have a lot of different methods to use. Architects, they don't have anything because they don't like it, because this is too difficult and they don't know anything about acoustics. They are not interested in the acoustics. They don't want to know what is alpha W, for example, absorption coefficient, blah, blah, blah. No, this is too much. So it must be as easy as possible. So if you have any idea to make it more easy, you are welcome.
Yeah, I imagine the execution of this modeling, the executed machine learning would be hard indeed, but maybe it could also provide a simple model and maybe remove some features that we were initially inserting. Maybe I don't know if it finds some relations between them, but yeah, I understand.
Very good idea.
And I also would like to ask you if you thought about using some psychoacoustic coefficients maybe as parameters.
What kind of parameters do you mean?
Maybe loudness or sharpness, since they are maybe closely related to acoustic comfort.
But as indexes, or?
Yes, as input parameters to this model. Think of them as.
But as you can see in this method, mainly I'm focused on architectural parameters. Acoustical one is actually the only reverberation time is
okay.
Still, I think it's too difficult for architects, maybe too difficult for architects, but sorry, they have to know what is reverberation time. The other parameters are mainly connected with architectural parameters. So like shape or scattering elements, like columns or something like this. So this is translation from acoustics into architectural language. Loudness might be too difficult for architects to understand.
Okay, so simple as possible, only reverberation time. Yeah. Okay.
Exactly.
And also, I've got a last question. I promise.
No
It's about.
I'm sure Ella is enjoying to have all this conversation.
Oh, okay, great. It's about the institute, actually. My main line of research is on the scattering coefficient measurement in the reverberation room. And I didn't see it in the listed as one of the measurements you do in the institute. So I was wondering if there's a reason, if it's because it has a narrower application. Is that any reason for it?
The narrow application also, but Building Research Institute, this is the institute which are, as I said in the beginning, this is notified and accredited body. It means that we are doing tests for products which will be sold in the market. So we are focused mainly on parameters which are important for materials and for building materials and building elements, parameters which producers they need for CE marking, for example. And sorry, scattering is not on the list.
Yeah.
Only sound absorption, sound insulation, and so on. Scattering not yet. So that's why we are not using this, because actually we don't have. We were thinking about the sound scattering, but we had no interest from producers, so we are not doing this right now.
From a commercial point of view, right? Yeah. Okay. We hope one day it will be more valued. At least I hope so. Thank you. Thank you very much.
Yeah, thank you very much. I will ask Sophia to make one last question, and then we are reaching our time limit. But please, Sophia, go ahead.
Hi, good morning.
Hello.
Hello. My English is not very well, so if someone can translate it for me, please.
Pode falar, eu traduzo.
Eu sou arquiteta por formação, né? Minha primeira graduação é em arquitetura e estou me especializando agora na pós-graduação em acústica. Então, muito disso é bem real para mim, tipo, como que é complicado, né, para passar para os arquitetos como aplicar a acústica na prática. Eu não sei se eu não identifiquei na apresentação, mas se existe uma limitação na volumetria, mesmo sendo espaços públicos, em que o método poderia passar a ser aplicável. E essa seria a minha primeira dúvida. E também quanto ao tamanho das estruturas em si do modelo, no caso, que isso a gente vê dentro das simulações, né? Que, por exemplo, tem coisas que são muito pequenas que aí passam a não ser visíveis. Se isso seria uma limitação também para esse tipo, para o método.
Tá, ok. Vou traduzir então. Obrigado, Sofia. Sophia, she is an architect. She had her undergrad in architecture, and now she's doing a master's, mestrado, né? Você tá fazendo?
Isso.
Her master's in acoustics. So, and she said she suffers from that situation that you just explained, this difficulty in communicating between the two worlds. But she has two specific questions, and it is one regarded with the volume. Is there a maximum volume that your method can be used with? And the second question is regarding the size of the structures. If you are considering, if you ignore small structures, or how do you deal with different sizes of structures?
About volume is if it's a very big, then this is 0, points. For big volume, 0 points. So the goal of the method is to make the volume smaller, maybe not as small as possible, but smaller to force to architects to not to do the big, huge enclosures. I try to translate them that smaller volume is better acoustics.
But there isn't a limit. Your method could be used with any size of public spaces.
Yes. And the second question was about?
Sofia, repete, por favor, a sua segunda pergunta.
E a última seria, no caso, mas aí, no caso, com o que ela respondeu, eu acredito que aí seria aplicável qualquer coisa dentro da sala. Né, porque seria, por exemplo, em simulação, nós ignoramos algumas coisas que são muito pequenas.
Sim,
e aí, se isso também seria ignorável diante do método. Por exemplo, um ripado ou coisas muito pequenas já não seriam mais visíveis.
Sim. Tá. Eu vou... what she was asking is about the details. So if you have structures that are very fine, in very small sizes, in your method, they are simply ignored, right? You're just looking at the bigger dimensions of the structure, right? Let's say if you have some small benches on your rail station, the subway station, you're not taking that into consideration, right?
No, it might be taken into consideration, of course. Because it's not, but also in small volumes, still the speech intelligibility might be not enough. If the volume is small and no absorption, still we may have problems with proper speech intelligibility. So if we have simple, only small but no absorption, no scattering, lot of noise, still the there might be problems with acoustical properties. So of course it's even for small, but of course it depends what do you mean small. Yeah.
Yeah.
50 cubic meter, maybe not enough because there are no 50 cubic meter underground stations. Yeah, but 500 cubic meter also apply.
Great. Guys, I think we've reached our time limit. I'm sure people would still make questions. People are really interested in your talk. I think you could notice that. Once again, Ella, thank you very much for taking the time to present.
Thank you
your
also
work
very much
us.
that you wanted to listen to my.
And you didn't. I don't know if you had access to the. Well, it was in Portuguese, but people were talking at the YouTube chat as well, and they are creating a group and want to apply the method here in Brazil.
Okay.
So you might get some contact from us, and your method might swim over the ocean and be tested around
so
here.
Give me some feedback.
Yes, we will. Guys, let's open our mics and give a big round of applause for Ella for this talk. And Ella, once again, thank you very much.
Thank you.
Thank you very much. It was a pleasure for me to present you my small acoustical world.
We enjoyed it. And guys, next week we keep on with our seminar. Next week we'll have Luana talking about psychoacoustics. Thank you very much, and till next week. Enjoy the rest of your week. Ciao, ciao, pessoal.
Cheers. Bye-bye.
Bye.
Oh, fine, Bruno.
Ella, you're popular.